making decisions. This is really going to get to a lot of the core of what you're going to be doing in Java. And today, we're going to be talking about the assignments that we're doing this week. Now, there's a lot going on this week. We have 3 assignments. One of them I'm going to be doing with you in Moodle. Okay, you're going to see the video online. I'm going to walk you through it and do it. But you need to follow along and do the assignment with me and then turn it in. Okay. There'll be no class this Thursday. Okay. I'm preparing for a big event here on the island, and my boss has graciously allowed me off. So we're preparing for the big Mariana's Festival of Hope at the amphitheater with what's that? Franklin Graham, and yeah. So it's a big concert, by the way. You guys are all invited. It's a nice concert. Yeah. Okay. So we're going to be looking at decision making, the logic behind it, flowcharts. We're going to be looking at creating a sample flowchart, and I have a sample scenario we're going to work through and create a flowchart together today. And then we're going to take that flowchart and we're going to create a sample program from it, and then we're going to demonstrate standard if-else logic. Omar, could you get that for me to shut that? Thank you. And we're going to look at and, or, and not logic. These are all operands that are used in Java. They're very important. We're going to talk about also, hopefully by the end of the class today, the switch statement, which is an alternative you can use for if-else. Okay. All right, let me catch something real quick here. Let's see. Omar and Christian. Okay. And Joanne has not come in yet, correct? Okay. All right, let's jump back in here again. Go ahead and go into your Moodle course room, and I want you to look at, there's 3 things that you're going to see in there. One of them is the 3 homework assignments, which one of them I will be doing with you. There is a project 1, which is going to be due not next week, but the middle of, I think it's March 5th is when it'll be due. Okay. And then the midterm is next week. Midterm will be next week. All right. There's no class this Thursday, so you guys can, go do your class from your home, or you can come in here and use the room. I don't think they're going to be scheduling for anything. There's also an extra video tutorial I put in there that will kind of go back over again the concepts of decision logic and conditional statements. All right. Pseudocode. Pseudocode is nothing more, it's nothing but just sitting down with pencil and paper and writing out your thoughts of how something should be laid out in code. Okay. Many times it's easier just to sit down with scribble something on pencil and paper and say, okay, these are the fields I need. These are the types of data types I'm going to use. And this is the logic structure that I expect to happen. So for example, say your game requires someone who is 16 years of age or older to play. One of the first things you're going to do is you're going to say, are you 16 years of age? That's decision logic. If they don't meet the criteria, if maybe it's the logon that's validated through some other source, if they don't meet that criteria that they're actually 16 years of age, then you don't let them into the game. That's one example of decision criteria. Other examples are simply things like, does A equal 20? Does a variable equal a certain number? Is a person's name Mike? It's a good name. That's decision logic. Decision logic always evaluates to true or false. All right. So use pseudocode. You just write down with pencil and paper. 22 years ago, I took a class here at NMC. Velma doesn't know this. There was a gentleman here who was teaching databases, and he talked about the same thing, getting out with pencil and paper. And we were using a Visual Basic for applications back then. And that was my first foray into programming, by the way, here at NMC, just to let you know. But pencil and paper, writing it down. All right. So what I'm going to show you, there's a free site called draw.io, and in draw.io, we'll actually create some a sample flowchart. All right. So with the flowcharts, we're going to validate different types of flow. Okay. Hang on one second. Omar, didn't I count you? I thought I got you a minute ago. There we go. Okay, let's jump back into this again. All right. Gabby, are you good? Okay. To draw.io. Draw.io will allow you to use a Google Drive account, and I think you can connect this to your NMC account because it's Google connected. And with draw.io, you can basically create any types of charts you want. We're going to create just a simple flowchart using decision logic. Now, there are two types of decision logic we're going to look at. One is sequence logic. Sequence logic is just basically step 1, step 2, step 3, step 4, step 5. It is a sequence of steps. That's all it is. With sequence logic, it looks a lot like what you see here. It's just like how to get to someone's house. All right? Very straightforward. With decision logic, you split the decision path off in multiple directions. This is where you're asking a question. Do you want to do this or do you want to do that? That type of question is true or false, yes or no. Here's an example of a flowchart using decision-making logic. So you can see right here that the question is, you go west on Algonquin Road, you turn left at Roselle Road, and it asks the question, is the expressway backed up? And so you have to answer the question. If yes, you're going to do something different. If no, well, there's also different logic. All right, I'm going to exit out of that for a second. Basic flowchart for a moment. I have here on draw.io, let me scroll it up here because I only want you to see one side. The first side is steps to fix a light bulb. It's very basic. So you're asking the question, lamp doesn't work. So what do you do? Well, is the lamp plugged in? Right? This can also be very well, if you're wanting to capture troubleshooting steps, you guys who are in the help desk. Someone else is coming on and you're saying, okay, let me show you what you do. Here's your little decision guide, your flow chart for what you need to answer, right? So is the lamp plugged in? Yes. Well, is the bulb, is it burned out? Yes. Replace bulb. No. Repair the lamp. Or is the lamp plugged in? No. Plug in the lamp, right? Very basic decision structure. Now let's look at it from this standpoint. I wrote out a scenario, which you'll notice in the code examples and the assignments I've been giving you, I put a scenario out there for you. And I ask you to think about this word problem. How are you going to deconstruct it and break it down? So here we have a scenario, need to validate a user. So we say, please enter the user's age. And really the scenario is like a relationship compatibility question, right? Is the user 18 or older? Yes. Go to step 3. Otherwise, exit. Does the user like ice cream? Right? This is just a question. Yes. Go to step 4. Otherwise, frown at the user. All right? Step 4, does the user like coffee? Yes, go to step 5. Otherwise, walk away from the user. All right, and then step 5, user is your friend. Yay, you have a new friend. All right, so how do we break this down, though, into a decision matrix? Well, simply let's just drag a box up, and we're going to state the criteria. What is the statement we need to figure out? So our step 1 is please enter user's age. All right. So the age is there. And now we need to figure out the question. Questions are usually always done with diamonds. Diamonds in a flowchart, they signify decisions that have to be answered. And so the decision here, we're going to basically drag an arrow down. Is it not going to let me drag an arrow? There we go. There we go. So we drag an arrow down, and we're going to ask the question, is user 18 or older? All right, so I'm going to make it pretty, and I'm kind of going to make it wider. So if yes, so we're going to go down to the next decision. I'll pop another decision in here. Click on this, connect it, and if it's yes, we go down here. And so this question is, does user like ice cream? Okay. Then we have another decision, the next step. The next one is, does the user like coffee? So, does user like coffee? All right, so far, all of these logic statements have been single, I forget what your textbook calls it, single truth statements, right? Single alternative statements. There is a dual alternative statement, which we're going to demonstrate now by going back to, is user 18 or older? If user, let's see, step 2, is the user 18 or older? Yes, go to step 3. Otherwise, exit. So I'm going to grab a process, because that's really what that is when we're exiting a program. We're calling a process. So no exit program. All right. Does the user like ice cream? So here we're not necessarily exiting the program, but it's still a process. And we're saying, what is the question? Does the user like ice cream? Whoops, I'm asking the question, right? What we're saying here, frown at user. But the logic statement here continues. And so we're going to continue down here to the next part of our statement. And you can drag this over and kind of get a better understanding. All right, so you can see here's the first question, enter the user's name. Is the user 18 or older? No, exit the program. Does the user like ice cream? Frown at the user. And then what are we going to do? Go ask the next question. The next question is what? Does the user like coffee? Well, if the answer is no, we walk away, which is an action, which is also saying that we're going to, oops, we're going to exit the program. Right? Does the user like coffee? Yes. So now we get to the final state. Yes, the user likes coffee. And what is our requirement? User is your friend. And we have an additional statement. Yay, you have a new friend. All right. It seems silly, okay, the statement. But just by laying it out like this, we can begin to decompose the problem statement or the logic of what we're trying to model in code, right? All right, so let's do this. I'm going to open up IntelliJ again and close some of these diagram pieces just so I can see just my my flow diagram. All right. What is? Is there a way to? There we go. All right. So I'm going to open up IntelliJ, and I'd like you to go ahead and try to do this with me so you can get some practical experience in creating this if-else logic. Okay. Okay. When IntelliJ opens, just go ahead and create a project called conditional logic. And if you need, tell you what, we'll just do it again from scratch so everyone is on board with me. We'll create the project, the home screen. We're going to make sure we have Java selected, your latest JDK. Click Next. Create a project from template, command line app. Next. We'll call this, what is this? Friendship. What should we call this? Friendship. Friendship, yes? Okay, friendship, yes. All right. For our purposes, go ahead and expand your project. Go down to the source, down into your package. Right-click on the main class, and we're going to change the name. So you get in the practice of doing this. We're going to call our class Friendship. Yes. Our creativity abounds, isn't it? Okay, so we have Friendship, yes. This is our class. I'm going to bring this over a little bit so we can see both windows. Can everyone see that okay? Yes? All right. So, public static, we're going to simulate a user's age. So we'll go ahead and say scanner. Do scanner. And do you remember what we supply in here? There you go. Okay. We're going to state the first part of the process. And what is the first statement? That we're alerting the user. Please enter user's age, right? And then we say scanner dot, what is it? Next, next int, right? We're going to assign this to something, and we're just going to say int user age, just for short, right? All right. Remember, it's always a good idea when you write a little bit of code, compile it and test it, right? So we're going to go ahead and compile it and test it. From IntelliJ, we'll just run it right there. And it prompts us to enter the user's age, right? So I'm going to say 19, and I enter. All right, so far it's working correctly, right? All right. And notice down here in the terminal window, it says process finished, exit code 0. All right, so we have the user's age, so let's ask the first question. Is the user 18 or older? So if user age is greater than or equal to what? 18. All right, we have our first if statement. Let's talk about the construction of this statement. It's very straightforward. You have an if and then a parenthesis, open and close parenthesis. Whatever is inside the open and closed parenthesis has to evaluate to true or false. So we're just applying a simple numeric statement here. The user age, whatever we enter, is going to either be greater than or equal to the number 18, right? All right, we'll hit enter, and then we're going to say if this is true, we're going to add another if statement because that's the next part in the logic, right? So if this evaluates to true, we come down to the next question. Does user like ice cream? So in order to do that, we need to ask for the scanner again. Now, in typical if questions, if statements, you don't have to put, apologies guys, you don't have to put the curly brackets. But in this instance, the curly bracket isolates the code block. So whatever is inside the code block is the part that's evaluated if the condition is true. If you don't have this code block and you say system out print line, you are older than 18, next line, system out print line, you are a person. I don't know what to say. All right. If there is no code block, meaning curly brackets, the only thing that will be evaluated right after the if statement is the first system out print line. Let's verify it. We run the program. I clicked run, didn't I? Oh yeah, I did. All right. So it's asking us to enter the age. And so I'm going to enter, instead of 18, I'm going to enter 17. Now, what do you think is going to happen now that I've entered 17? Which lines are going to print? Based on the rules in Java, the only thing that will print is the first line underneath the if statement, because there is no curly brackets. So what will happen is when I hit enter, it says you're a person. It doesn't say that you're 18 or older though, because it skips. However, if I do this, we run the program again. Now it's going to print if I'm 18, which I'm going to go ahead and type that, 18, whoops, wrong place to type, right? 18, I hit enter, and it says you're 18 or older, and you're a person, because it's in the code block. All right, so we have that statement. So let's go down to the next if statement. This is called a nested if. Nested meaning that there's another conditional statement within the original. So now we're going to request scanner to ask another question. So scanner, let's see. Well, actually, we're going to ask the question. If I can type, so there we go. Do you like ice cream? And it's a good idea, since we're only expecting a simple answer, do this. Say y or in. So you prompt the user what type of information you're looking for. So we're going to say scanner again. And we're going to say next, what is it? Text, string, next line. There we go. And next line is going to prompt us for a string. So we're going to say string answer. Now we need to evaluate the answer. Is answer a yes or a no? All right, so how do we do that? If, what would you do here? Answer equal to y? This is one of those gotchas in Java. All right, this won't work. And the reason is this operator here, the equality operator, is comparing memory locations. So it compares the memory location and the information inside of it. So every time you type a string, it's a new memory location. And when you compare memory locations, they're going to say, are these two memory locations the same? And Java says, nope. Oh, they're not. Even though the contents inside the memory location is. So Java gives you another way to do this. All strings come with this statement called equals. And you can see there's another benefit, the equals ignore case. So why is the equals ignore case a wonderful method? Your user may type lowercase y versus uppercase y, right? So we're going to say answer equals uppercase y. And we're going to ignore case. All right. So again, curly brackets. We're going to type system out print line. You're cool. Because you like ice cream. All right. You guys understand so far what we've done? All right. So we're going to save it. Again, we're going to test our code, because you always test your code incrementally. Don't go write your whole program and go, oh, it doesn't work, and you get overwhelmed with all the little issues. All right, so we're going to test it again. All right, so we have enter the age. I am 18. Ah, you're older than 18. You are a person. Do you like... Something happened here, didn't it? Yes. So at this point, what happens if you put the age below 18? What will it do? Okay. Let's run the program again. If we say 17, nothing. Because the logic right now has jumped right out. Okay. Now, we haven't got into the next piece, and that is the while loop. And the while loop is actually the topic of next week. All right? But this is the process of how you lay out your logic statements. So let's do this for a second. We're going to kind of take some of this code out for a moment. And let's look at the else statement. The else statement is what we call dual conditionality. So it's a dual condition. A single condition is if it's true, that's all we're looking for. And the program just jumps on out and does something else. But in dual conditionality, it says if it's true, do this. If it's false, do something else. Right? All right. To make this more interesting, let's put a public static void method, and we'll call this one exit. What's that? Oh. And we'll put a system out print line. Says let's see, you are not old enough for me. And there is a code that you can use. It's system.exit. And if we look into the source code of exit, it requires a status, and I believe if we use 0 is the correct one. I'm going to tell you a funny story. Really, system.exit is what's used when all programs are finishing. You'll notice down here it says process exit code is 0, right? Because anytime a Java program is finishing, it says system.exit, and it passes this information to the underlying operating system. It tells it to kill the thread. So in a Windows box, it might say exit code 1. It all depends on what your operating system is. All right, here's the funny story. There was a young developer at the that was working with us on Fort Knox, and we were coding an application to process new recruits. And he had it in his head that when the process was done, that you typed system.exit. The problem with that is that it kills the whole Tomcat server that the application was running on. And so every time we were debugging this code, every time the recruiter would do this one particular task, the whole application server would crash. We're like, what is going on? We can't figure it out. So then we started digging through the code, and we found out that the developer had just said, well, I thought when we're done that we exit. And so it was actually killing the whole application server at that time. All right. So we have a program here called a method called exit, and we're going to tell it to exit. So we're going to call our method. And to prove that it exits, we're going to put another system out print line down here called I probably won't be called. I have a lot of confidence, don't I? All right. So we'll try this again. The criteria is to test that it's less than 18 to see that it calls the else statement, and to ensure that this last statement isn't called. All right, so we'll run it again. We enter the user's age, 17. You're not old enough for me. And it exits. It never calls this bottom statement because we put in the system exit here. However, if we comment this out and run the application again, we'll see by entering 17, it's going to hit this first logic piece. Is the user greater than or equal to 18? No. It's going to drop down to the else block, call the exit. You're not old enough for me, and then it's going to exit the exit block, come out to the next phrase, which is I probably won't be called, which in this case it will be. All right, make sense? Okay. I'm going to close, let's see. Now we'll leave this open, but I'm going to take this piece of code out here in the middle and take that out. And let's talk about the next part of our if-else logic, and that has to do with, let's see here. Yeah, let's look at what happens when we misplace a semicolon. So I have a variable. I'm going to say this is int age equals 19. And I'm going to have an if statement. If age is greater than 18, semicolon, all right. This is an often mistake of developers. They think, oh, I need to put a semicolon after the if statement. When you do that, it negates the logic. It doesn't call. It doesn't work the way you think it does. And so in this example, when you run the program, it says try me, but really the interesting thing about it, by putting this statement here, we have we're telling it it's the end of the condition block just by doing that. And so trying to say apply an else, IntelliJ is being too helpful. IntelliJ is going to tell me, this doesn't work. There's an error here. And the reason is because the semicolon. If the semicolon wasn't there, that would work. You guys see that? The semicolon causes this else to be treated like there is no if for it to be attached to. And this is one of the rules in programming in Java. An else always has to be attached to an if. An else can't exist by itself, right? Else is without an if. And it's because of the semicolon. All right. But with it, you can say, and we'll change this to 17. Let's see. Yeah. And we'll run it. So you can see that which one is called. Right? Okay. The other thing we need to consider here is we looked at the double equality. We've talked about strings, how you can't use the double equality. You have to use the actual dot equal sign. And then there's also the not logic. So what if it's not equal to 18? The exclamation point equals basically says negate or reverse the typical logic. So if the age is not 18, meaning you expect a double negative, really. You expect the false statement to be what's true. So if the age is not 18, try me. Otherwise, exit out. So in this scenario, when we run it, you'll see that it says try me. The other option you could do is adding double truth statements, where both statements have to be true. And this is done with the double ampersands. The double ampersands are those little squiggly things that we sometimes use to say and this, right? In Java, you have to use both. There has to be two of them. So we'll just say true. So to make this make more sense, let's do that. When the age is 18 and it's true. Well, let's apply this to a variable. Boolean, what do you think? By the way, name your Boolean variable something that suggests a truth statement, right? Okay, so this may make more sense to you now. 18 and likes ice cream, right? So now we're saying, is this a true statement? If both scenarios are true, it's going to spit out, yes, try me. But what happens when one of the scenarios is not true? Well, think about your criteria for how you make decisions. I'm going to go to the grocery store, and the grocery store needs to be clean and have ice cream. And if it's not clean and it doesn't have ice cream, you're out of there, right? So if that's the case, when we run it, in this case, the person needs to be 18 and they like ice cream. And this first statement doesn't fall true because it has to be both. But there's also another option. This one is called, by the way, the AND logic, right? But you also have what's called the OR logic. And the OR logic uses two pipe symbols. So now we're saying 18 or they like ice cream, right? In this scenario, if you use one of what you're saying is one of them can be false, and it'll still evaluate to true. Now, Java does something interesting here. When you have an OR scenario, it's better on the machine's memory to always put your truth statement first, something that you know will always be true. Because when it reaches the first truth statement in an OR syntax, it doesn't care about the rest. If the next one is false, it stops and it says, okay, I don't care about the rest of the variables. All right, let's jump back over here to... So we have single alternative ifs, which is the scenario we described here. We have dual alternative ifs, where it's an if-else. Okay. So let's jump back over here and do what I prefer. I prefer that you actually use the curly brackets. And when you're writing your code, even though the compiler, the Java programming language, will allow you to do this without curly brackets, I prefer it because it helps to teach you to think about what logic is being encapsulated in the code blocks. So in this instance, we're going to wrap both of these in the curly brackets. And this also gives us the ability to encapsulate multiple things. We could have, say for example, that we wanted to set the value false for likes ice cream. We could do that right here. We could say like ice cream is false. And so now it becomes a control statement. Say the control statement is not likes ice cream, but has visited. And the control statement, the initial is false. Has John been to class? No. John hasn't been to class, right? I'm messing with you, John. And so if John has visited, or the value comes up in a scenario where he has, we could set the control logic in the if statement to set it back to true. This becomes helpful later on when you're trying to spit out some other criteria. Maybe there's another method that needs to be called, and all of these are important for determining future conditional logic. Okay. You guys have any questions so far with the curly braces and dependent statements within a block? All right, we've also looked at multiple if-else statements, right? Where we've nested them. So if 18 if they like ice cream, if so on and so forth, right? Um, let's go back to our original example here. And where was my drawing at? There it is. So we're going to set this back up for a moment. I'm going to back up my code just for a bit so you can see this. Okay. So let's do this. We're going to say system out print line, enter user's age. We have the scanner. Then we say system out print line. Do you like ice cream? We're going to call scanner, what is it, next line? Yeah. And then we have, let's come down to our system logic here. If ice cream equals ignore case, y, curly bracket, system out print line, do you like coffee, right? So when we ran this before, we enter the person's age, and we ran into a problem. What do y'all see as the problem here? Yeah. It went, are you older? You are a person, and then it exited because the scanner line here causes a problem. So what you actually have to use, I believe, is yeah, next. Yeah. I think it's next string pattern. What is the other way we could do this? We could also do this with the, you could do this with the, what is it, the J option pane, and show input dialog, right? So null, and the question is, please enter user's age. What's that? The show input, the J option pane is the JAVAX swing components. And what this allows you to do is attach the dialog to a parent. And in this case, we're saying, no, we're not going to attach you. So we're saying null, not attaching the option. Okay. And this is going to give us a value of what? A string. So we say string user age, right? Then we need to convert the user age. So how do we convert the age again? Do you remember? What's that? So integer parse int, right? And this takes a string, so we're going to pass in the user's age. And we're going to assign this to a new variable called age. Right? I think there's also, is it string value? Right? No. All right. Okay. So we're going to take the age, set it over here. And what do we always say to do with magic numbers? Don't use them. But what do we replace instead? We'll always create a constant, right? So public, static, final, int, and what are we going to call this? Good age. I don't know what to. My mind is blank here. All right, so we're going to replace the magic number with a constant, right? Because if we use the age again, and then again, and then again, and we think, oh, I want to change it. Now we only have to change it in one place, right? All right, so we've accepted the value. We're going to replace this question here. You're older than 18. What are we going to replace it with? We're going to say J option, pane, show input dialog. Not show input dialog. What do we want to say? Is there others? Do you remember? Show. There it is, message dialog. All right, so we say null for the parent object because we don't need it. And we're going to replace this with you are older than, what is our magic number? Good age, right? Because we don't want to keep repeating, typing a value that we might change. So then we'll take out these two statements and we have to ask a new question, right? J option pane, show input dialog, null, and what is our new question? Do you like ice cream? Do you like ice cream? Okay. So then we're going to output this value, string to what? What do you want to call it? Think about it. We want to make the value something that symbolizes whether or not, yes, they like ice cream. There you go. Likes ice cream. All right, but now we need to, how are we going to deal with this one? Likes ice cream, ignore case Y, right? And then we're going to replace this one with, let's do another one. Just for time's sake, I'm going to copy here because it's, let's say null. And do you likes coffee? And then we'll say if not, no, we gotta evaluate it first, right? If likes coffee equals Y. Do you see another magic constant that we could change? Yeah. We can make this another magic constant, right? Public, static, final, string. Yes. There you go. You guys are thinking. What about this one? Public, static, final, string. Absolutely. All right, so we can replace this magic constant here with yes, yes, right? If likes coffee, ignore case. And then we need to say something, right? What is our statement at the end? User is your friend, right? So J option, pane, show message dialog, null. Yay, I have a new friend. All right, but we're left with some questions here. In our program, we say, do they like ice cream? If they don't, we frown at them. Well, how do we handle that here in our if statement? So if they like ice cream, then we say else. We need to frown at them, right? Make a sad face or something. I don't think the JavaX swing has emojis, but maybe you could, there's other libraries in here. You could actually display like a sad face. And yeah. All right, so let's make this null. And I am frowning. Sad. Sad life. All right. We got a problem though. Look at our code logic. If we're going to map this to the friendship diagram, it really should map to a process that repeats some state of these questions, right? So how would you do that? Do you think we could map it into a method that asks the question that you could call? Some of you are nodding your head, some of you are looking at your phone, and it's okay. It's all right. But think about it. Think outside the box. How would you do this? You know that you can create methods. So we're at this point here. I'm frowning, but our logic shows that we continue to ask the question, do you like coffee? Well, I mean, one of the ways we could do this is obviously just continue asking the question inside the if else, right? You could do it that way. But we have another problem there as well. How do we answer that problem, right? The variable likes coffee is constrained in this block of code. One way you could do that is declare the variable up above string likes coffee, and we could set it to implicit null. Then all we have to do is take that out, but we still have the problem down here. It's still not set, is it? How do we set it? So likes coffee. Just set it to yes for right now. All right. So if they like coffee, we're still going to ask the question. We still give them yes, I have a new friend, and then we exit. Okay. Should we watch the program crash and burn?
Yes.
Oh, you guys want to see me fail, don't you? All right, here we go. So we're running the program. The first dialog should pop up any minute now. There it goes. Enter the user's age. Well, I'm only 17. What happened? Well, why did it exit? Well, yeah, I'm not, but look at the code though. Why in the code what happened? So here's the age. It hit this first code block. Now IntelliJ gives you this nice feature. I can collapse that code block to see what's after it. What's after it? Nothing. It's done. Right? It calls the else and that's it. Right? Okay, so let's call it again. Do I want it to do something else besides exit? Should I tell it to say, sorry, lie? Huh? Try again next year. There we go. J option pane. Show message dialog. Oops. Null. Try again next year. All right. So we got it in our else statement, so that should answer that question. All right, let's see what happens. Good news is we don't have any compile time errors, right? All right, so 17. Try again next year. All right. So let's run it again though, meeting some of the criteria. By the way, if you're wondering what just happened there, I double-clicked it, and IntelliJ was telling me that it kicked off 2 processes. Do you really want to do that? It says stop and just run. So that's what it was doing. All right, so we'll say 18. Okay, you're older than 18. Not really. I said I was 18. Right, but okay. Do you like ice cream? No. I'm frowning. Yay, I have a new friend. All right. So you have questions there that you have to evaluate in your logic. Now, what time is it? It's 4:33. All right. We've touched a lot on the if and the if-else statement. There's one more conditional logic set that we can look at, and that is the switch logic. Is anyone familiar with switch logic? Has anyone read the book this week? Yes, Mr. Rogers, I read. Right? All right. By the way, your forum question this week is kind of a look back. It asks you a question about singletons. And this is a research question for you. It's going to ask you how to construct a singleton, its relationship to a private constructor, and so forth. So you make sure you, it's a huge topic within the Java programming community about singleton classes and their purpose. Okay? All right. So let's, I'm just going to create a new project. We'll leave this one alone for a minute. And create a new one from the command line. I'm going to expand this so we can have a little bit more real estate up here. Okay. So a switch statement is like your if-else logic, but what it does is it controls the execution because there may be more than just one option. In an if-else statement, we could say if this, then that. A switch statement says, here is give me the number of your month that you're born. Well, that could fit into any number of months. That's an excellent area to look at a switch statement. So say we use, let's use J option again. J option pane, show input dialog, null, enter the month you were born. in, let's see, as a number, right? So we're going to say string month number. Now we'll test it, make sure our code is running good, running well. And enter the month. And there you go. It exits the code. All right, so we know that's good. So let's set up our switch statement. So switch is going to take a int for the month. Let's pull up our PowerPoint real quick so you can see this before we get into it. Okay, here we go. Can everyone see that clearly on the screen? Okay. Now again, the recording will be available. I hope to have it uploaded today on YouTube so you guys can go back and listen to the lecture again. So the switch statement, it's like what the slide says. It's an alternate to the if statement, but it allows you to test a number of different values. When Java first came out, you could only test an int. You could only test numbers. Now you can test things like characters and string values, and so forth. All right. So these are your keywords: the switch, the case, break, and default. All right. And we're gonna go through those in a moment. With the switch, you're going to identify the variable that you're going to pass in. Notice that you have the curly brackets, and then you have the cases that you're trying to match. So the year should match either 1, 2, 3, 4, 5, or if it doesn't match any, then it will display the default. All right. So let's jump back into our code example and just look at it. So we're going to declare int month, and we're going to assign that by doing integer parseInt, passing in the month number. We set our curly braces, and then we type case. So if it's 1, use this special special colon syntax, and you output something. So we'll output JOption pane, show message dialog, null, January baby. Have a good day. Now, at the case statement, if you don't, thank you for being good, guys. Yeah. 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 All right. So with the case statement, if I don't put a break, it's automatically going to go to the next case and do the evaluation. So for example, case 2, JOption pane. I might as well just copy this because this is going to take too long to type. I got a better idea. Let's just do this. Public static void show message string message JOption pane. Oh, what did I do that for? I think I was. All right, there we go. I don't want to have to keep typing that long statement. So now I can just do this. Show message. Show message, and this one is February baby. Case 3. Well, it's going to take a long time to type, isn't it?
Yes.
March. All right, and we're going to put a default. Show message. No idea when you were born. Okay, so if we run this, enter the month. I'm just going to say 7. No idea when you were born. It's not a very smart calendar, is it? All right, so if we run it again and look at some of the other options. 1, January baby, February baby, March baby.
Also continues.
Yeah, because there wasn't a break. So the break, it tells it to exit from that control logic. Now, when we run it, we don't get that that strange logic. We'll say 3 for March. March, baby. That's it. All right. With the switch method, you can also pass in strings. So if we, let's do this. Public, static, void, test, month, num. And if you watch what I'm going to do here, now I've encapsulated that logic in a separate method. And because I'm going to retype all of this again using strings, I'm going to create a new method. And I'm going to call test month as text. So I have the enter the month you were born, first 3 letters. Don't need that. Change month number. Now my case has to change because these are ints and they have to be strings. So we'll say January, February, March. Test the month as text. Run it again. Enter the month you're born, the first 3 letters. Let's say Feb. February baby. Right? Now this does bring up an interesting scenario. Can I do something like this? How about, it's better to do it up here, right? What if I type in something like, give me a second here as I try to figure out what I'm doing. What if I type instead of capital F, E, lowercase eb, I type in FEB? What do you think is going to happen? Yeah, it's case sensitive. No idea when you're born. How would we get around that? But where would we want to control that? I'll tell you this. This is actually practical as well for your database classes. Okay, you want to control the input and force the input into your database to always be a certain format. Because then when you write your queries, it's easier to write a query against one logic statement instead of two. In your databases, the more and statements you add to the where logic, the more CPU intensive the query becomes. So as a developer, if you force your logic to always expect a certain case sensitivity, then it makes it easier. So what would I do here? Because I have uppercase and lowercase, right? An easy thing to do would just be make all of these uppercase because I control that. What I don't control is what they're going to input. At this point, though, there's another way to handle this. Makes it hard to see off the screen here. You can take the month number and assign it to itself like this and say to uppercase. You guys understand? So now I've controlled the input. If I enter it in all wonky, doesn't matter. I've done my part. The other thing that I can do is I can say month number equals month number, and let's see, what is that? What I'm looking for? Substring 0, comma 2. Actually 0, 3, I think it is. What the substring does is it says only take the first 3 characters. Because all I'm expecting is 3 characters, right? So if we run this, let's run the program though, debug it, and kind of see what's happening as we go. Have you guys used the debugger yet in your code? Have you tried it yet? All right, so select your code statement in here. Make sure you put the breakpoints where you want it to be. Click debug main menu. Debug the main method. All right, so it's going to run. It's going to make some connections to a port on the back end, and I'm going to enter some text. So let's say I type in January. All right, if I hover over this, it tells me the text. Can y'all see that? It's kind of dim. It says January. And now I'm going to send it to uppercase. So I'm going to step one spot. So now month number is uppercase. And now I'm at this level. So I'm going to go one more time, and month number is January. So I've used my substring. 0 is remember, they do it weird in Java. 0 is always the starting position. And so then I say go 0, 3 spaces. So 0, 1, 0, let's see, 1, 2, 3 from 0 position. So yeah, that's how that works. All right, so now if I continue to break through it, you're going to see it hits January, and it's going to ask the question, am I January? And yes, it is, and the application finishes. Okay, let's break out of this for a second. Go to Moodle. I think I got to quit. There we go. I need you to go to Moodle, and by the way, Draw.io is free. I've used this application for years. I use it for my work, and it saves it to your Google Drive, and then you can export it as ping images. And unless your employers require Visio or something else, I think the paid program you can export as, yeah, maybe. VSDX, is that Visio? Yeah. Anyways, let's look at your assignment real quick for this week. Because, as you know, I'm custom creating these assignments, and it took me about 6 hours yesterday to really think about how I should apply what you're learning this week and what you've learned in previous weeks. All right. So, the singleton class. Please take the time and just Google it. Say Java space singleton, and you'll get a plethora of information. You need to demonstrate different ways to create it and post links to resources for other people to read it, resources that you find. This is important when creating code because a singleton exists only one time in memory. And there's certain ways you can create it that make it beneficial. Certain things only need to exist one time. All right. You have some videos out here, logical operators. There's also a video I put out there on condition logic. And here's the first scenario. Take Care. Do y'all like Take Care, the insurance company? Yeah. All right. Well, anyways, Take Care sells medical insurance, but has begun thinking about other insurance policies like life insurance. The proposed insurance policies that they desire to offer include one for $5 a month for an individual, which provides $50,000 for loss of life and limb, $7 for $75,000 of loss of life and limb, and the final plan is $10 for $100,000. If a second family member wants to be insured, it's 2% less the monthly rate for each additional member. Okay? So think about that. You need to be able to program it so you can deal with the logic question of, am I asking for a new person to join, to have life insurance? So think about how you're going to do that. I recommend that you do this with the J option pane because the scanner, sometimes you have to catch these weird scenarios where it'll just exit the program on you. So use the J option pane when you're doing this. The exception is if the second family member cannot choose a life insurance policy that's greater than the first. Because, people like to do that, right? Oh, I'm going to get $100,000 life insurance and pay less than my... Yeah. That's the exception. So you got to catch that. Now here's the program details. You're going to write a program that prompts the user for types of life insurance. So put it in the J option message. These are the life insurance policies available. Please type one of these. All right? And then you're going to read that input on the back end and make a decision with it. Then you're going to display the question, do you desire to insure an additional family member? If yes, then display the available insurance type and ask the user to input the insurance type they desired. This here is an excellent opportunity for you to use draw.io or a piece of pencil and sketch out your flowchart. Okay, so you can kind of map out the logic statements one by one. Then display the question again, do you desire to insure an additional family member? If yes, do the sequence again. So think about how can you encapsulate that logic into maybe a different method that's going to be called again, right? If no, then calculate the total monthly charge and display the following. The number of people insured, the total cost per month, the type of insurance policy or policies chosen, and the total life insurance policy selected. So as you watched me with the J option dialog, I output the information to a variable, right? And so maybe one of the things you could do here is have a method that says how many, that just counts up the number of members that are being insured, just keeps track of that. And you can do that very simply by creating a variable up here, right? You can say int number of insured. And currently it's set at 0. And so when they answer the question, do you want life insurance? You could increment that number. How do you increment? You guys know how to increment a number? So, yep. So, let's put that method over here where it's easier to use. Number of shared, you can do it like that. That increments by 1. We haven't got to this yet. Or you could say like that. Or you could say number of shared is number of shared plus 1. That's the most readable because you're taking the current value, you're adding 1 to it and assigning it back to itself. That make sense? Okay. The other part of this is the total cost per month. So, again, double total cost per month equals 0. Total cost per month equals total cost per month plus whatever the policy value is. So you're incrementing the total cost throughout your class. The type of insurance policies and policies chosen. So maybe you want to do that by just saying a string policies and policies equals policies plus new policy, right? Whatever it is, you're just adding it together just so it'll display. If you want to display in new lines, remember you can use the new line character. Okay? All right, so that's the first one. The second scenario is a new PC gaming store called Fantasy Digital. I was not creative enough. I apologize. All right, it's opening on island. It provides custom-built gaming PCs for people to come in and rent time to play the game. Business model of the store has a flat rate per hour each customer pays, which includes some older games for free. Flat rate is $10 an hour. And this is the base rate for when you add new games to it. If the user wants to play the latest release games, okay, games of 1 to 3 months old from the purchase date is an additional $10 an hour per play. Games for 3 to 6 months are $5 an hour additional to the game rate. Okay, and so on and so forth. And then you have the exception. Some games have a legal restriction on them that no matter if they're out of the date range or not, it's $2 on top. Okay, and then you have all of these games that you can choose from. Just create a constant for these. All right, now this is where it gets interesting. You need to create, and I'm going to do part of this code for you in the video tonight. You're going to create a inner class that stores the name of the game, the month it's purchased, and the license restriction. That'll be an inner class that you use that'll have all of those games. Okay? We haven't got into using arrays yet or any of that, so we won't do anything fancy with looping. But we'll just create constant variables for all of these using the new data type of the game class. All right? And I'll do part of the code for you tonight, and you can see some of that. All right. The last one is scenario 4, simple dice game. It's just called math dice game. Yeah, that's what I called it. Very simple. You have 4 dice, and just work through the logic on these. Okay. All right. The project is 2.5 weeks away yet, but I'm putting it out here so you have time to look at it, kind of churn through it. All right. The homework is a little more intense this week. Last week you only had 2 assignments. This week you have 3. You also have to think about the midterm that's coming up next week. I won't be here on Thursday, but I will be answering questions via email. And again, please take the time, use the video that I post for dealing with this one, right? Yeah, this one. No, not this one. This one here. I'll do the code posting the video on part of this one, and you just have to finish the rest. All right. You guys good? All right. I'll be here for a few minutes if you have any questions.